So in this video we're going to talk about radical notation with nth roots, and a lot of it is going to be, from this first section, is going to be simplifying. We're going to be doing all of this without a calculator, because I know you could just type this in on your calculator and get an answer, but that's not the point here. On your quiz and on your test you'll have problems where you have to do these without a calculator. So you're going to be doing yourself a huge disservice if you just go through this lesson and just plug numbers in on your calculator. You're not going to know how to do this. Because let's look at this first example. We're trying to figure out the fourth root of 1,296. I'm trying to figure out what times itself 4 times would give me 1,296. Well, if you don't know what that is, you're going to have to learn some way to be able to get to that answer. So one of the ways that we could do that is by using what's called a factor tree. A factor tree is going to give us all of what we call the prime factors of 1,296, all the prime numbers that multiply together to give us this 1,296. So the way you start it out is you look for 2 numbers that will multiply together to give us this number. So I know that 2 goes evenly into 1,296. I'll tell you why I circled that here in a minute. And to figure out how many times 2 goes into 1,296, you might say, well, I don't know how to divide without my calculator. Well, you're going to have to learn. So here's some tricks. To divide by 2, you're essentially taking half. Well, you might say, well, I still don't know what half of 1,296 is. So a fast way to do it is to take half of each of the places. So in other words, half of 1,000 is 500. Then we go to the hundreds place, so I have 200. Half of 200 is 100. Then I go to the tens place, which in this case is 90. So half of 90 is 45. Go to the ones place, half of 6 is 3. Add those together and you get 648. Now I circled 2 because it's prime. Prime numbers are numbers that the only numbers that divide into it are 1 in itself. So the only 2 numbers that multiply together to give me 2 are 1 and 2. So I circle it because I'm done with that branch. So now I go to the 648. 648 is even, so I know that 2 is going to work again. And 2 is prime. 2 goes into 648 324 times. And 324, there's a bunch of numbers that go into here. If you try, I know you can do 2, but let's look for other numbers as well. 4 goes into here, because we know that 4 goes into 32 8 times, and 4 goes into 4 1 time. Now, notice I didn't circle 4. 4 is not prime, so I have to continue going with that one. 4 breaks down to be 2 times 2. 81, well, 2 numbers that multiply together to give me that would be 9 times 9. There are others, but that's an easy one. And 9 breaks down to be 3 times 3. So this is what we call the prime factorization of 1,296, because if I multiply 2 times 2 times 2 times 2 times 3 times 3 times 3 times 3, it'll give us 1,296. Now the key here is this is the fourth root. So the way I simplify this is, because all of these, if you notice this factor tree, it's all under the fourth root. I want to see what I can take out of that fourth root. So the way we do it is, since it's the fourth root, for every 4 of the same number, we factor an item out. So in this case I have a set of 4 2s, so I can factor out a 2. Here I have 1, 2, 3, 4 3s. A set of 4 3s means I can factor out a 3. And you multiply those factors together. Well, 2 times 3 is 6. Oops. So the fourth root of 1,296 is going to be 6. Because 6 times itself 4 times would give us that number. Let's try another one. 216. Now I know this is even, so I know that 2 is going to work, but I want to show you other tricks as well. Here's a trick to see if 3 works. If you don't know if 3 goes into 216, just add the digits together. 2 plus 1 is 3, plus 6 is 9. 3 goes into 9 evenly, so that means 3 goes into 216 evenly, and 3 is a prime number. 3 goes into 216, well, 3 goes into 21 7 times, 3 goes into 6 2 times. So 72. 72 is not prime, because 72 breaks down to be 9 times 8. 9 breaks down to be 3 times 3. Nice thing about circling numbers is I can see that I have not finished with this 8 yet, so I need to go back up to that one. 8 breaks down to be 2 times 4, and 2 is prime. 4 breaks down to be 2 times 2, and those are both prime. So again, it's a cubed root, so for every 3 of the same number, I get to take one out. So I have 1, 2, 3, 3s, so I get to take out a 3. I have 1, 2, 3, 2s, so I get to take out a 2. And this answer is also going to be 6. Let's try a couple of other examples. Now you might be saying, oh, wait a minute, I can't do this problem. This is decimals. Well, If it's a decimal, there's a real easy solution here. We're going to change it back into a fraction. To change it into a fraction, you look at what comes after the decimal. That after the decimal, I have 0.27, or just 27. Now that 27 ends with 3 numbers after the decimal, so I'm going to write down a 1 with 3 zeros, because 27 divided by 1,000 gives me 0.027. Now I'm going to take the cubed root of the numerator and the denominator. The cubed root of 27 is 3. Please don't say 9. We're not taking 27 divided by 3. We're saying, well, what times itself 3 times gives me 27? Your answer is 3. So what times itself 3 times gives me 1,000? Your answer is 10. So the cubed root of 0.027, or 27 thousandths, is going to be 3/10. Let's do the next one. Again, we're going to write this as a fraction here. So this is going to be the 4th root of 16 over a 1 with 4 zeros, or 10,000. Again, it's not going to be 16 divided by 4. It's your numerator is not going to be 4. It's going to be the 4th root of 16. What times itself 4 times 16 is 2. The 4th root of 10,000 is 10. Now this can be reduced. 2/10 reduces to 1/5. So that's your final answer. So when you deal with fractions, it's not that hard either. Let's look at another type of example. Here I have the cubed root of 8 x to the 9th y cubed z to the 12th. Well, for the cubed root of 8, what I'm going to do here is I'm going to take and break this up. Well, you don't have to write this down like this every time, but sometimes it makes it easier, especially here at the beginning. We're going to take the cubed root of everything. The cubed root of 8, the cubed root of x to the 9th, the cubed root of y cubed, and the cubed root of z to the 12th. Everything is going to have a cubed root taken of it. So let's start out with the 8. Well, the cubed root of 8, that's 2. The cubed root of x to the 9th, though, when we have a variable here, what we do is we take the power divided by the root. We take the power divided by the root. 9 divided by 3 is 3, so I have x cubed. So for the y, I take the power divided by the root. 3 divided by 3 is 1, so y to the first, or just 1, or just y. And 12 divided by 3 is 4, so this is going to be z to the 4th. And there's your answer. So why don't you guys work this last one out on your own? Take the 5th root of 32, x to the 15th, y to the 20th, z to the 5th. If you need to, you can do a factor tree. If you don't know what the 5th root of 32 is, you can use a factor tree for that. Or just figure it out on your own. So go ahead and pause the video, hit play when you're ready to check your answer. Okay, so let's pretend you didn't know what the 5th root of 32 was. Well, you might know that 4 times 8 is 32, and 4 breaks down to be 2 times 2. 8 breaks down to be 2 times 4. 4 breaks down to be 2 times 2. So I have a total of 1, 2, 3, 4, 5 2's, and that's what we're looking for, a 5th root of 32. So for every 5 of the same number, I take one out. So I'm going to take out a 2. Now for these, I would take 15 divided by 5. Well, that's 3, so it's going to be x cubed. For the y, I take 20 divided by 5. That's 4. For the z, I take 5 divided by 5. Well, that's 1. So your answer is 2x cubed, y to the 4th times z. Okay, so that is this first part of 8-4. We're actually going to do this 8-4 and 8-5. We're going to do kind of different here. So 8-4 is, we're going to end this first part here, talking about how to simplify these radicals. In the next video, you're going to learn about how to rewrite equations for a different variable, and you're going to learn about the geometric mean. And then we'll also cover in the next video how to simplify equations where it doesn't work out nicely like this, and that's what 8-5 is all about. So why don't you guys, with this, go ahead and work on that first assignment that you will find on Moodle, and good luck on that assignment.